In this video, I am going to show you how to set up and solve for a specific heat problem. So let's read the problem first. Brian and Brianna heated a 75.0 gram sample of metal by placing it in a beaker and heating to 100 degrees Celsius. They placed the metal in a calorimeter containing 125 grams of water at 18 degrees Celsius, and the temperature of the metal and water was 24.4 degrees Celsius. Calculate the specific heat of the metal. So your first step is to identify all of the things that you know. We know we have a 75.0 gram sample of metal. We know that we are going to be heating it to 100 degrees Celsius. We know that the metal is being placed into 125 grams of water, and that metal is beginning, or the beginning temperature of the water was 18 degrees Celsius, and at the end, the temperature of the metal and the water was 24.3 degrees Celsius. So, when we lay all of this out, we're going to be using the equation Q equals, which is heat in joules, your mass of the material times the specific heat of the material times the change in temperature of the material. And since we're using a metal and water, we know that however much energy goes out of the metal is the same amount of energy that is going to be absorbed by the water. And so we are going to be using the mass of the metal times the specific heat of the metal times the change in temperature of the metal is going to be equal to the mass of my water times the specific heat of my water times my change in temperature of my water. So this is what my setup is going to look like. The first thing I want to point out is the change in temperature of my metal. The change in temperature of my metal is going to end at 24.4 degrees. It began at 100 degrees Celsius. And I'd like to point out the change in temperature of my water. It ended at 24.4 degrees and it began at 18 degrees Celsius. So make sure that you are calculating your change in temperature correctly. So here's what all my math looks like in the end. I ended up with 5,670 x being my unknown, which is my specific heat of my metal here, and that being equal to 3,347.2. Then I solve for x. I can ignore the negative sign. It's just telling me the amount of heat going out is equivalent to the amount of heat coming in. That's why it's negative. And so my final answer then is that the specific heat of my metal is 0.590. Don't forget your units, joules per gram degrees Celsius.